I'm not sure if anyone's having trouble hearing me or not, but we have a really great first speaker for you today. Her name is Shannon Wilkinson. I actually have had the pleasure of working with her on a past project. I'm sorry, hold on. You guys can't hear me? Oh, I guess I have the wrong schedule. Hold on here. Solutions track, 10:45. It says Shannon Wilkinson. Oh, I apologize, everyone. Okay, the first speaker is Rahul Dhawan. He's a senior security engineer at Postman. He's going to do a great talk today about detecting OWASP vulnerabilities with Postman in your APIs. I'm very excited about this. I hope you guys are very excited about this. And let's get started. Let's bring him out.
Hey folks, how are you doing?
Hey, how are you, Rahul?
I'm good. I'm perfect. Thank you so much for the invitation. Yeah, I'll be presenting the workshop on detecting OWASP top 10 vulnerabilities using Postman. So yeah, my name is Rahul. I've been working in Postman for the past 3 years now. Today I'm excited to lead the workshop focused on detection of automation of API security top 10 vulnerabilities using Postman app. Together, we will explore how to effectively identify and mitigate these vulnerabilities in order to enhance the security of web application. So I hope you will enjoy this 1 hour demo. But it will be less of a theory and more of the hands-on session for all of you guys. Yeah. Hope we can start. Cool. So in this presentation, in this entire workshop, I'll be covering OWASP API top 10 security vulnerabilities. The major focus will be on the detection part of it and the practical demos, and of course, the mitigation will be very brief, but our focus will be on the practical demos, right? So how I'm going to structure this workshop. So the structure of this workshop is designed to allow you to easily follow along with me. We are going to use the combination of two labs. I'm going to present you multiple vulnerabilities and solve it using Postman app on the OWASP Juice Shop lab, as well as one or two labs I'll be using the VAPI. Thanks to Tushar for his amazing labs. So I'll be utilizing that as well for the demonstration. I will demonstrate various ways to automate test and simulate attacks. All the necessary scripts and automation tools that have already been I think published in the public workspaces. I'm not sure if there is a way to share that public workspace with you guys. Let me just quickly pull that up to you. Yeah, just a second. Yep, we have this. So if you can go to the postman.com and you can open up this workspace, and this is public. You should be able to view everything and all of this. So you just have to have a Postman app for this entire workshop, and we should be good to go. And let me just see if I find a way to share this in the stream chat. Yeah, brilliant. Cool. Going back to it. So yeah, so how exactly I'm going to structure it? Like instead of following the sequential approach of cracking 1, 2, and 3 sequential manner, I will group together risks that are related and covered them in a single slide or section. For example, I will discuss A1, A5, and A2 together because the core of these vulnerabilities are the fundamentals are the same, but the impact is quite different. So yeah, let's begin. I hope you enjoy. So before we get into the OWASP API security top 10, I would like to provide a quick refresher on authentication authorization. This is because 3 of the 10 major risks on the list are related to authorization and authentication flow within the web application, right? So in short, what exactly do you mean by these two processes. So authentication is about verifying who someone is, right? While authorization is about determining what someone is allowed to do. So before logging into the application, before authentication, there can be a lot of security misconfiguration. That's what the entire, I think one critical issue in the API security top 10 list is related to the authentication, and the rest is once you get into the application, what all you can do, what all access do you have, and what all you can elevate to is something to do with the authorization. So you might be wondering, how does the security issue in authentication authorization process mentioned in the OWASP API top 10, OWASP top 10 list is different from API security top 10, right? So that I have made a quick flow chart for you to understand. So the red boxes that you can see here are the security issues mentioned in API security top 10, and the yellow one are the one that are mentioned in the OWASP top 10 web application security. So as evident in this flow diagram, OWASP top 10 houses the broader category of vulnerability that that entails the smaller one, the not smaller one, but that specific to APIs one. Like for example, for the broken access control, it entails the broken object level of authentication, authorization issues, and IDOR, which is also known as IDOR, and broken function level authorization issue, which is, and also the privilege escalation. So all of them a are a part of broader category vulnerability, which is broken access control, which is housed in the OWASP top 10 list, right? Similarly, with the authentication issue, we have broader list called broken authentication on the OWASP top 10, and the specific to API one in the API security top 10. So hope this clears everything to you. Before we delve deeper into the first one. So yeah, so broken object level authorization. I won't get into too much details here, but the simple and sober information is like it can occur when an application relies solely on user input to determine the access rights, right? Without considering other factors such as session information or user roles. So BOLA, or it is also known as IDOR, can be particularly dangerous in case of multi-tenant environment where multiple users or organizations share the same resource. So, for example, let's say in case of Postman, we have a huge collaboration environment for all the developers. If I'm able to access some random users collection by just changing the IDs of the collection, that's a major risk, right? Because I'm able to actually get the entire thing of your collection list, right? Request. So this kind of access control issue is considered as BOLA and IDOR, which is super critical. And we have seen in the past that a lot of breaches that happened in the past are because of the misconfiguration in the user role. Yeah. Yeah. So practical. So I'm more interested in showing you how to break the labs and how to utilize Postman to do things. So to demonstrate this vulnerability, I will use OWASP to shop to see this vulnerability in action. You can follow along with me if you want to. Uh, we'll be using just Postman app. If you don't even have app, you can just open the Postman uh, web app. It would be enough for you. And we will also be using the interceptor extension of Postman. So let's just begin with. So let me just show you what exactly the Postman app is. I like the vulnerable app that we are trying to break. This is owned by OWASP, and the interceptor that we are just going to install here. Disclaimer. So please note that this is not a marketing strategy for any product. I could have used Bobsuit. I'm using I'm opting for a more developer friendly approach in this workshop. This will allow developers to easily create APIs and identify security flaws using the same platform. So we all understand that developers have a good understanding of end-to-end understanding of how Postman works, because they spend a lot of time in using it to author an API, creating collection, creating contract test, and doing all kind of automation. So how about bringing the entire API security testing and house it into one single platform? So the developer, while creating their APIs, while testing their API for the integration test and all, they can also utilize Postman to do the security test. They don't need to have any separate understanding of any tools, and they shouldn't be any learning curve when it comes to testing their APIs for security vulnerabilities. That's why the entire purpose of this uh, workshop is to utilize Postman as much as we can and help developers and to shift left and think about security while creating the APIs, right? So yeah, this is the workshop, like the vulnerable lab that I'll be cracking into. Uh, let's begin with my app. This is my app, and if you want, you can. This is a public workspace, by the way. You can search for OWASP API Security Top 10, and I think I've already posted the link. So if you can see, you can just click on the link and get into this lab, right? And we will first start with installing the interceptor into this lab, right? So for the interceptor, we will have to install a Chrome app. So we already have this search for the Postman interceptor. You will get Chrome app. If you're not able to follow along, just you can just focus on this presentation right now. And later on, when I share the slide, you can just use these methods to try it on your own, right? So right now we have the Postman interceptor connected. I'll go back to the Postman app. So here you can see there's a bottom, we have a capture request section. So here we will configure our interceptor. So we have two options: either do the proxy, just like we used to do in OWASP, where we proxy the entire traffic of a browser to a specific app. So here we are going to just proxy the traffic of specific origin to our Postman. We don't want extra noise to be captured into the Postman. We just want one single thing to just connect it to our Postman app. So here I will be doing this. So where exactly the request should be captured? It should be captured inside the choose shop interceptor collection, right? And additional configuration, I will add the exact domain name of the lab that I'm going to practice on, right? As soon as I start the capture, you can see it. Everything is started, and we are starting to load it. So let me just refresh this. You can also see the color of the extension change to blue. That means it's active, and we have started to receive all the requests into the Postman app. Brilliant, we have the setup ready. So in the first, let's just in the first slide, I think this is about cracking the Bula attack, Bula vulnerability. So we will first try to create our own account in this vulnerable lab. Just enter any email address. We won't have to verify it. Test secops@gmail.com. I'll use the same for password, reset password, although this is not recommended. Never do this, but yeah, for demo purposes, it's fine. Now I'll try to log in, and everything is getting captured inside my Postman. We have the login request, right? Everything's there, perfect. Hope you can see the same thing on the public collection as well, right? Yeah, we have the same thing. Brilliant. So if you want to follow along, you can easily do it right away. So here we have the entire juice shop where we have multiple things that you can add into your cart. So let's try to see the cart of, like, let me add two things first in my cart, this and this. So we'll have two things in my cart. Would it be possible to see some random users cart? Like, it would be cool, right? If you can see the information on what others are purchasing. So we can see, this is my cart. The cart, like my cart basket ID is 44. Like if I send the request here, we should be able to see. So we don't. The good thing is we don't have to inject any cookie and everything. Everything is getting captured here, and just use the APIs out of the box and just make an API call. So this basket 44 will have two products for me. 24, which is Apple Pommes, and this is the second one. Cool. So yeah, if I change the number, what will happen? I wanted to see what others are having. What kind of cart that others are having right now. So it is possible, right? So ideally, we should not be able to see this, but because of the misconfiguration in their way, they are checking the permission on the basket in the backend. I am able to access other users' cart easily, right? If you want, you can also try out this using Postman. Just make an API call, change the ID. Should be able to make an API call right now. So yeah, so the first thing. So let's try other things also. Let me try to manipulate a basket. Let me try to add some product into user ID2, which is some random user, and I will try to add these two products, add carrot juice product into their cart. Cool. Let me find API, the post API item purchase. So we have quantity this 25. So if I do, let's say 24, let's say, yeah, product ID is 24 into my account. I should be able to, right? Yeah. Validation error, because 24 does not exist, either does not exist or it is already there. But if you can see, the 500 server is returned me with 500, but there's a lot of information that should not be there. Ideally I should just get 403 access denied or entity not present. But here I'm getting the complete detail of what server is running on. I can also see the entire details, and I can also see SQL queries into the app, right? In the error response, which is a big red flag that an attacker can easily get utilize this information to further change the attack to a more serious one, vulnerabilities, right? So ideally, what should happen here is this is basically one of the OWASP top 10 vulnerability. It will cover. I think this is called the excessive information disclosure, where we can see the entire details in these ones, right? Perfect. So if I'm not able to do this, let me just get the ID of some other basket. So this one, if I add here, 30, this is 3. Number 3, let me just delete the fruit flash, and we should have a delete API, 32. So if I try to add 32 product ID into 44 basket, I should be able to, right? Let me delete again. Perfect. Let me just delete it. So let me just add this same basket, this same product into basket number 2. Should I be able to do this? Okay, let me just try. Yep. So I got this unauthorized error. That means in the backend, they might have a check on the basket saying that you don't own this basket, so you should not be able to add this product into the basket. So one of the way we can fix this is like not fix this, bypass this, that you can just try to add this another time. This kind of attack is called FTP manipulation, where I can duplicate the same ID twice so that validation can fail. So let me just try to do this on 44. Or would I be able to do this? Yep. So in the first check, it just checked my ID, whether I have the access to add this 32 product ID or not. And then it just bypasses the second one and made an SQL query to update the basket with ID2 and add this product into this one, right? So this is one way of chaining HTTP parameter pollution attack with the existing one, which is the Bola, right? So cool. Let's just do other things as well on this app. The one last thing. We can see that there's a way of adding a review, right? Here, if I add a review, perfect. Let me just find an API that just posted the review here. There you go. We have the API ID. Success. So in the body, you can see that that again we have the message that I'm going to add on the product this, and the review will be added with the DFF. If I say, uh, let me just find someone, let me just find an admin, and on behalf of admin, I'm going to add this review. Say I'm not admin, and I will add a review on, let's say, the product number 1. Okay, there you go. Success. So in here, you can see that we have another review that says I'm not admin, and this is from admin, right? So this kind of issue can be super serious, where you can manipulate data and you can change this issue with the another issue and get and increase the severity of that vulnerability and do more damage to the website. It's better to actually do the uh, proper validation and proper authentication authorization of the customer who are trying to access the objects, right? The next thing is to, I guess, detection part. So yeah, detection. So identify all the objects and resources. So start by identifying all the objects and resources within the application that requires access control to be enforced. This may include files, database tables, and API endpoints and other data stores. Right. So while testing, if you see user IDs or any kind of object in the API, try to change it and observe the behavior of the API. If you own an object and the ID of that object is 123, and change it to 400, and should not be able to access that 400 or make any changes to that 400 ID. If you're able to do this, that your API is vulnerable to this attack, right? So testing of authorization bypass to test the application access control by attempting to bypass them and gain unauthorized access to the object and resources again. So if you have uh, any ID in your application, and if you try to bypass it, then you are definitely at a risk of one attack, right? Vulnerability. If an attacker can access an object or resources, they shouldn't be able to. It can be a serious vulnerability. So it can help, but the automation here can help. So if you can automate the entire flow of your APIs and automate in such a way that you cover each and every role against that API, that should be sufficient, but not enough. You have to manually verify the implementation of rules and policies over this object. So right, the one way is to protect against this vulnerability is to uh, like I will talk about the protection part in the next slide. Let's just come back to detection part. Sorry. To detection of so we'll be in Postman. How will we do the detection part? So let me just get back and we'll just hide this thing. So after this thing is complete, you can just completely delete all these requests within the collection, and just select everything and just do a hard delete on this, because we don't need them anymore. So when we do the testing again from start, we'll use it. Amazing. So how do we do the automation in Postman for these kind of attacks? Like, so I have created a simple automation for you guys here. So for, the 3 API that I tested right now manually. So I've tried to create the automation in such a way that I will use this different users and try to access these three APIs and assert on the response code. If I'm getting 200 or if I'm getting 401, that will be the deciding factor whether the API is vulnerable or not. So in this simple flow, I've created a user 1, I've created a user 2, and then I'll try to log in into this uh, user account and get the access tokens, save it into the environment variable, right? And then I'll try to make an API call on these 3 APIs using user 2 login. So as mentioned here, user 2 will try to log in to try to access the IDs of user 1, and the entire automation will work. So there are 2 ways to run the automation. One is to just using the collection runner. Boom, you can run it, and you can just start seeing the failing request already that we asserted on 401 and we're getting 200. That means the API is vulnerable, and we should recheck the API and authorization flow before proceeding with the production deployment. right? And the another way that we can use it to create is by creating a monitor out of it. This monitor, if the developers can create a monitor, they can basically run this monitor at the time of the deployment. So whenever they deploy or push anything, they can integrate this monitor to the pipeline so that these tests can run and give them a very basic checks that your APIs are secure and they are not vulnerable, at least not vulnerable to the IDORs or Ebola attacks. So we'll just have to run this monitor and things should be working perfectly fine for you. Yeah. And we also have another way for the non-developers, like for the non-developer persona who doesn't have enough context on writing tests and writing complex test cases. So for those customers, we do have a way to visualize these kind of attacks in Postman. And we recently released this in last September 15 release, and which is the flows. So let me just quickly walk you through this entire thing. Yeah. So don't get scared. It seems complex, but it's super simple. So this is so basically the non-developer persona. Let's say the marketing team members or the product manager who doesn't have a good like who doesn't want to write a test cases or to test all the end-to-end flow of an API. They can definitely leverage the flows. So what exactly this means is we have a couple of requests piled up together to test whether the API is vulnerable to broken object level authorization or not. Right. In this case, I will log in as user one. So how exactly it works is I will look for the request that is already present in my list of collection. Let's say I will look for the juice job automation. I will log in as user one, right? And the environment will be populated from the environment that I have selected here, right? And once the request will give a success, then it will give out the access token, and this access token will be fed to the different request, which is this one. And this request I've selected for the API that I wanted to test, which is the view basket of different user, right? And the environment variable here is the do show of access control one. So the URL will be picked from here. And the second thing here is if I want to run the automation in such a way that it enumerates all the IDs. So I can have a list of IDs. So I know that IDs are not GUID IDs or UUIDs. They're simple numbers, incremental numbers. So I've just created for the test purposes, I've created 5 numbers, 1, 2, 3, 4, 5, and all of this like this, and fed them into the user ID. So whenever the request will run, the user ID will be updated with picking the one number incrementally from this list, and the access tokens will come from this request. And if this request succeeded, that means it's vulnerable because it should not succeed. It should give me 403. And if it fails, that means it is not vulnerable, and it should give me a success response, right? Yeah, let me just clear this, and we can also run this flow, right? And also just to remember, this is not a this is still in a beta phase. We are going to release it publicly properly for every single customer in Postman for all the plans. But for now, it's just beta and testing phase. And yeah, let's just run it. Cool. You can see it's running. You can see the tiny automation that you are seeing and all the flows that is being running and where exactly the path, the execution flow moves from this collection, this request to this next request. And once everything is executed, we will see the log on this console. X API vulnerable to broken object level authorization because everything succeeded. It should fail, only then it will throw a success error, right? So where exactly it is useful, as I said, to illustrate the end-to-end working of an API. Let's say you have let's set of 10 complex admin APIs, and you want to create an illustration so that you can explain it to all the team members within your team, right? So and you can also route them through the kind of risk that you are into if you kind of expose this API to public and if you make them public. So you can just to illustrate the entire end-to-end flow of an API, you can use the flows. And you can if you can also deploy, you will get a webhook, and you can use that webhook to integrate the result of this flow to some other entities as well. So, yeah. So for non-persona, we also have an automation. Cool. Let's move to prevention. Cool. So implement a proper authorization mechanism that relies on the user policy and hierarchy, right? So implement RBAC if possible to ensure that users are only able to access object and resources that they have been granted to, right? Explicitly permission to access. So this can help to prevent unauthorized access to object and resources. So if further, if you are in a like a small startup and you have very basic access control mechanism where you map a specific object with specific user one-to-one mapping, it's better to start planning to move towards a more complex access control mechanism, which is RBAC, where when you scale more rapidly, then it's easier for you to accommodate more complex roles towards your object. Where if you want to assign a non-admin user an admin access of only one single entity, that would be possible using RBAC. It would be much less complex, and the security would be a little bit high, better than one-to-one mapping of the objects, right? It's recommended to have this. I know it can be super complex to implement and test it out, but the long-term goals of the RBAC and the benefits are overweighs the entire complexity of the system. So apply the the principle of least privilege to ensure that users are only granted the minimum level of access necessary to perform their job and functions. Right? This can help to prevent unauthorized access to the object and resources. So deny everything and only allow the user what they need. That's it. That's the simple principle. And to minimize the blast radius, it's recommended to use a random and unpredictable value of GeoID, of record ID. This is because let's say if your API is vulnerable, let's say for some reason, and and the ID of the object is very simple, incremental value 1 2 3 4 5. So it's easier for the attacker to enumerate and fetch all the details from all your users, right? But if you're using UUID, it's much difficult to predict the UUID value of the object, and the enumeration will be a little bit harder. But it's not possible. It's possible, but it will be harder. So attackers would have to find different ways of getting the list of all the entities or all the UUIDs and then feed it to your vulnerable APIs. But it will add another hurdle for the attacker to exploit this vulnerability on your API. So it's better to work on a way where you can reduce the blast radius, right? Yeah. So write tests to evaluate the authorization mechanism. Do not deploy vulnerable changes that break the test. So let's say right now in the many software development lifecycle, the role of security engineers come at at the least the most part of it. Right? So once the application is developed, security engineers are then informed about the new product and they have to do end-to-end testing. So it's better for security engineers to work with developers to integrate the complete set of RBAC changes within their unit tests, so that whenever they do a new release, uh, a test will run, and if the pipeline is failing, they won't be able to push anything. So you have to make sure that we cover every single edge cases within the unit test, so that it's, we don't miss any edge cases at the time of release and at the time of configuration changes. Right? It is easy to maintain, and developers and it can be maintained by a collaborative effort of developers and security engineers within the same team. So moving on to our next vulnerability, which is broken user authentication. So this will basically happen when there's a poor implementation of authentication methods. So it refers to the improper implementation of user authentication and session management mechanism. This can include issues such as weak password, session hijacking, credential stuffing, and brute force attack, and session fixation, etc. Right? A lot of things go wrong here. Account takeover via you might have heard a lot of bug bounty programs that they award highest bounty for the account takeover, right? So you might have heard of account takeover via reset password flow, account takeover via linking Google account or Google account to some random user's account, some different users account, and gaining the access of their account completely, or email account takeover via the email verification flow. So all of these is a risk that is that come under the broken user authentication flow, right? So let's see this in action. Again, we are going to use a Juice Shop web app and try to exploit authorization using Postman app. So here we need to find, so in this app, you can also find the scorecard. So that's inside the scorecard, you can easily find which exact vulnerability you want to solve. So if I want to solve broken authentication, okay, come on, yeah, and password strength. So it says that log into administrator user account credential using previously changing them without changing them using SQL injection. So we simply they expect us to log into this dashboard using admin account without leveraging the SQL injection vulnerabilities, right? So let me just log out, and first let me just see how what's the email address of the account of the admin. So for that, we can just explore through the dashboard and look for the reviews and all the email addresses that is being exposed here within the reviews. So you can find the admin email address lying around in one of the comments, like this one, admin@juice.op. So we'll use this admin account to log in. Here I'll put a random password and try to capture it on Postman. So interceptor is here, it's ready. Login. It failed, and I think we have to configure the interceptor one more time. Perfect. We got the login. So once you have the login, you can see the body as well. And inside the body, you just saw this thing. So one of the ways to perform the attack on this specific is to do the brute force attack, right? So we can use any very common password list dictionaries to perform the attack. So I'll be using a dictionary that I've crafted here just to demonstrate on this for this lab. So what I'll do, I'll go to the broken authentication and login endpoint. This is the login endpoint, and this is the password. This is the admin's username and the password. And I can use the Postman runner here to and upload the dictionary inside these in a file. And the dictionary has to be in a CSV file, because let's say if you are trying to select multiple parameters, like if you want to also brute force this and also brute force the username, password, and other parameters. So for those kind of use cases, it's better to have a CSV so that you pick up the exact column name and put it into these parameters and start enumerating the requests, right? So we'll go to runner, we'll select the files. I'll go here. We have password.csv. If you want to preview, you can also preview the file right now. So we have a list of 200 common passwords in a CSV format. And observe that the name of the column name is password. And this is the same column name that we have added in the password as an environment variable. So if I just run this, it'll take some time, but after some time, you will see the password. One of the test case will pass, and you will see the success right here. Cool, we got one. So this is the one. So if you want to see the request header or the request body, so admin123 is the password. So we can copy this from here, put it here, and log in. That's it. So we are admin right now, and we have just passed this as, and you can see the cart of admin and everything is visible from here, right? So going back to detection part. So look for how do we detect this kind of thing while developing our APIs, right? So look for missing or ineffective authentication controls. Start with automated scanners to scan your endpoint for authentication related issues, right? Manually review the code, check for password policies, check for rate limit policies. So even if your endpoint is vulnerable to these kind of attacks, at least if you have a strict rate limit policy, attacker will take it will be harder for the attacker to exploit this vulnerability, right? So you will reduce the blast radius of this attack on your application, right? And if you can continuously monitor the log, you will see that the behavior of the attacker. Like if he is trying to do one single kind of bad attack on your API, that means there's something wrong with the API that he found. So you can quickly reverse engineer and see what's happening with your API, then you can fix it internally, right? So focusing on reducing the blast radius, even if you are vulnerable, is one of the like better approach to look into security. Let's look for the worst case that can happen to your API, and see if you have the necessary control implemented on that API. Right? Even if things go south, you are protected with the other different kind of protections in place, right? So we can also look for the password entropy. Do not allow the special characters. Like the length of the character, the password should be 16 characters, and it should be rotated after a specific time period of 90 days, let's say. And lockout mechanism should be there. So let's say someone is trying to do a brute force attack on your API, you can implement a lockout mechanism where customer can the attacker can just try out, like let's say 5 requests per minute, and after 5 requests he or she is blocked from the your application for at least 1 or 2 minutes, and then he should be allowed the access to the API, to the application again, login page again. That kind of mechanism again reduces the blast radius to a very to a very extreme content. But yeah, slow brute force can also be attack can also be leveraged here to bypass these kind of control mechanisms. This is not a good solution to completely rely on rate limit and lockout mechanism, but yeah, it will definitely reduce the blast radius here. So yeah, so test for broken session management. Session management is a critical component for the authentication that ensures the user remain authenticated throughout the session, right? The other thing is like password policy has to be super strong for your applications. So prevent all the authentication endpoint with rate limit, having strict policies, and also implement lockout mechanism. MFA is recommended, but if you're implementing MFA, make sure you are doing it right, because misconfiguration in MFA can also lead to account takeover. So yeah, so we have to be sure that whatever security mechanism that you're putting in these area, those has to be compliant and has to be very secure. And capture mechanism is super important. So let's say some attacker have automated a bot to make an API call, very slow API call, just to stay under the radar of rate limit. So the bot capture mechanism will be able to mitigate those kind of attacks and will reduce the load on your servers, right? So you can have purchase some kind of a third party, or even build an in-house capture mechanism where the capture will be solved automatically as soon as you load your browser. If you're as soon as you are logging in using a browser, right? So that can be implemented here. So detection part. So how, as I showed you in the Postman app, how do we detect these kind of things? You can use the basic this kind of automation where I can have the admin login and I can implement create a monitor out of it. Let's say, let me just create a monitor for you guys. So if you monitor a collection, it will run the collection at a specific interval of time, and you can also use Newman to trigger this automation via CLI as well. So here nothing is required. Choose shop authentication mechanism, and every time at this time, and yeah, when you run this, you will be able to see the tests and everything will be fast, right? Yeah. Cool. So moving forward, so broken function level authorization. So This will happen when you allow unprivileged user to access other privileged users' resources and function, right? Little confusing, right? Confusing with what's the difference between BOLA and function level authorization. So function level authorization is a process of controlling access to specific functionality within an application. So based on the user role or permissions, for example, an application might have admin role, which that allow users to access admin functions only. So while a regular user only accesses its own function, but if he knows about that endpoint, he would be able to access the admin API. Let's say in Postman itself, we have uh, dashboards for, let's say, enterprise account, right? We have some kind of analytics dashboard. It is housed in a different API, which is not visible to free users. So if free users find out that there's an endpoint, and if you try to access that endpoint, and they get 200, that means that we haven't added a proper authorization mechanism to authorize the user to access that page, right? Basically, we should map that the access of that page with the user access and check whether the user role is authorized to access the admin page or not from a free account. So these are kind of a resource or function level checks that we need to make for the features that are only available to specific plan IDs, right? So if those features are broken, then we might be vulnerable to MAFLA issues, right? So when the function is authorization is broken, the attacker can bypass the access control and access functionality that they should not have access to. This can be done by modifying or manipulating parameters or data that is sent to the server or by exploiting vulnerabilities in the application code. So incorrect implementation of RBAC can also lead to this issue. So earlier we mentioned that one of the mitigation strategies of BOLA is to implement a RBAC that can reduce the blast radius and also minimize the risk of this class of vulnerabilities in your APIs. But if you do the RBAC implementation incorrectly, right, then you will might be exposed to BAFLA issue, which is broken function level authorization. That might that might be equally dangerous as BOLA, right? So if RBAC is important, if you misconfigure the RBAC, then you might face this kind of issues in your web application. So, yeah, time for the practical. Again, we are going to use a combination of two labs here. I will be using the juice shop to make the simple to access one of the endpoint that is not authorized for the normal user to access, and I will also use VAPI lab, which and I'll solve the exercise number 5, which is again BAFLA's exercise, right? Let's go back to our juice shop. I will log out from this, and here you can see we have. So yeah, so there is some. Let me just show you the scoreboard. So here there is one of the broken authentication exercises, and here I wanted to access the admin page. So BAFLA. So here access and admin section. So admin section is a administration section of the store, right? So in here, administration section is basically hidden from the normal user. And if you try to find that endpoint somehow, you should be able to access the website as an administrator, right? So let me just go back and to find. So this is the Angular app, right? So we can look into the source code and find the routes that are hard coded into the code here. So don't get too nervous while seeing the code. So it's just a simple thing. We'll go to the application, or we'll go to the source, and within the source we have main.js. Within the main.js, we have entire thing. So if it is not if it is in like in a not a good viewable manner, you can just use the beautifier to bring it to JSON. Just lint it out this way. So here you can see we have list of things. So if I want to search for /search, this path should be here in this source code. Hard code is somewhere just here, right? and this should be somewhere else as well. And the first one we found it here in REST search product. And what else we have? Mhm. Cool. So yeah, we can see that search is here. That means the admin endpoint has to be there as well somewhere. You can see there's app administrator. So that means there is a functionality for in this app that admins only can access. So you can see title admin, what all we have here, and path is administrator. So here we found the router. So inside the router, you can see all the different kind of paths. So you have administrator part, you have accounting and about address section, and all of these kind of paths. So as a normal user, you won't be able to view this path. So basically, from your perspective, these does not exist. But if you are an admin, you should be able to access that. So if I just quickly copy this and go to this section, I should be able to access this. There you go. We have the admin section of the same app, right? And if you want to see the accountant also, there you go. You have the accountant. But as a normal user, you are just a user who don't have any access to anything. So what should have been done in the backend is this: the user access should be mapped with the at the function at the function layer. Like who all can access the admin page. There should be a proper role mapping. Like if the user have this kind of permission, only then this user should be allowed to view the administration page. So those kind of checks has to be done at the backend properly. But in this scenario, there is no check. The endpoint is hidden, thinking that if nobody knows about it, it's kind of secure. But that's not how it works. We can dig deeper into the code and find the hidden paths as well. We would have used some other tools like directory traversal and all. But for this lab, I just chose to dive into the code itself and look into the router function where you can find the list of all the paths mentioned. Yeah, so we have solved one exercise. So the second one is I'll be using the VAPI. So in this VAPI, I have this hosting somewhere around here. Yeah, it shows me that yeah, I hosted this in my own local system. So you guys won't be able to. You have to basically uh, go to the GitHub page and spin up the Docker instance to access this lab VAPI. So yeah, let me just go back. So I'll be solving the fifth one, A5, which is Bafla. As you can see, you can register so as per the description, it says that you can register yourself as a user. That is that's it, or is it something else? So it's basically challenging us to find other routes that we can use to list down all the users within the app, right? So let's just create a user with this name, test123, and all these credentials. If I try to log in with this user ID that I just got in the response 7, I should be able to get this. So I think this API, this lab is already vulnerable to Bola attack. So if I do one, I should be able to get the response of the one if it already exists. Yep. For the 2.1, I will get the test user 2 already in my database. So yeah, we have. So what if we do admin? It won't work because there's no route for the admin. If I do users, so see, I'll be able to list down all the users within the app. So in the web application, this kind of APIs might be hidden from the customers, from the normal user. But if you enumerate deeper and find out these hidden paths, you might be able to get the paths that are not properly protected, and you should be able to access those endpoints. So yeah, that's the critical issue of broken user authentication. And this is second top 2 of the top 10 vulnerabilities. Cool. So detection part. So use manual testing to find the misconfiguration in the RBAC is one of the things that I have just previously shown you, that we can use this kind of automation. to create user, do this kind of thing, and add all your critical APIs into this collection. And here you can, I think basically if your service own have around 20 or 30 endpoints, just dump them all, create a lot of users, a lot of roles assigned to this user, just to complete your all the edge cases. And with this combination, with the permutation of these roles and permission, you can just try to access these APIs and expect a response. Like if a user is only allowed to view this but not allowed to make any write operation on the DB, so the user should be also able to receive the 401 error, right? So these kind of permutation you can write for your own APIs and add this as a handy security contract within Postman, so that whenever there is a major release within your service, you can run this contract to be ensured that you have tested for the very basic access control vulnerabilities that is possible in your web app account, right? This is one of the automation that we recommend, and I think we also maintain these kind of things internally where we check each. It's difficult to check the each and every edge cases in case of RBAC implementation, but we leverage automation as well internally. So test for common techniques like using Bafla, so such as parameter tampering can detect uh, test for parameter tampering or session hijacking or even privilege escalation as well. So this can help identify any weaknesses in this API. And automation is suggested, but it's recommended to go through the code and see the policy itself. Like there could be a typo, there could be some kind of thing that we have missed, and because of that, the entire API is exposed to public, right? This can happen a lot of times, and automation is something that is useful, but not the final. Uh, that not the only thing that we can use to test. Code review is super important in this scenarios as well. So the principle of least privilege again is recommended, where uh, we can while designing the access control policy. So which means that deny all the access by default, right? Requiring explicit grant to specific roles for access to every functions, right? So use a centralized authorization system. So like if possible, implement a centralized authorization mechanism such as OpenID or to auth connect, so that to ensure that all the requests to the API are properly authorized. This can help prevent BAFLA vulnerabilities and also the IDORs by ensuring that authorization is handled consistently across the entire APIs. And of course, we have to perform the regular test on the APIs and ensure that developers add these kind of basic tests into their unit test, because unit tests already have a lot of function level test of the API, right? Why not we just add those access control level tests also in the UI in the unit test that can maintain at the time of pipeline itself. Whenever you run a pipeline, if it fails, that means you have to reject it and review the policy from your end, right? Cool. Uh, Next one, I'll be jumping to security misconfiguration. Uh,
Hey,
so
Rahul, unfortunately, we're running out of time and we have to get to the next speaker.
okay, yeah, just wrapping up. So yeah, I'm almost done with this. So we have 5 minutes, right? I'll
We
just
have
run.
1 minute.
Perfect. So yeah, so basic. So definitely, let me just wrap it up quickly.
Okay, great.
Yep. So for the basic security misconfiguration, we can definitely we do in Postman we do maintain our own automation template that we use. So we have the Cosmos configuration, we have security headers, we have authorization things. So these are templates that we can use to test out the cores misconfiguration or even the SQL injection and all. So at the time of development, developers can basically utilize this template to test out the APIs against these common misconfiguration, including security headers, and try to embed them into the development pipeline. That would be great, right? And similarly for the injection attack, also I had prepared a proper lab for you guys. I think we are out of time already. So yeah, even in Postman templates, we can use uh, these predefined security templates, which is injection, SQL injection that can be We can utilize a entire dictionary to run the automation and ensure that your APIs are protected with SQL injection against the SQL injection attacks. Right. Yeah, wrapping up. So the entire workshop was centered for the developers who can also leverage API security within the Postman and ensure that the APIs are secure end to end at the time of development itself, and don't have to rely on security engineers. And for the security engineers as well, we have lower your workload by just uploading the low hanging fruit, detection of low hanging fruits to the developers, so that you can focus on critical issues like business logic issues or other critical issues at the time of the stage or pre-prod testing, right? So this way you can offload your work and focus on critical things. Yeah, I'll share the deck with you guys. You can refer to all of these project and all of these tools that I've used to do the testing. I guess we don't have enough time left for the.
Yeah, unfortunately, we don't have enough time for questions.
Yeah.
That was a wonderful presentation. I know everybody loved it, and I know you're on social, so if people do have questions, they can reach out to you, maybe on
Definitely.
LinkedIn or through. Perfect,
Yeah.
Wonderful. So I just want to thank you so much for your time, Rahul. That was great. Really appreciate it, and thanks again.
Thank you so much for having me.
Yeah.
Bye.
So.